All right, so here's a video for note 7-2 sample proportions. So here's an example of a sample proportions type problem. A polling organization asked an SRS of 1,500 first-year college students whether they applied for admission to any other college. In fact, 35% of all first-year students applied to colleges besides the one they are attending. What is the probability that less than 32% of students in the sample applied to colleges other than the one they are attending? So this is going to seem very much like a z-score problem, but instead of saying 32% of students applied to colleges, it's 32% of students in the sample applied to colleges other than the one they're attending. So instead of looking at individuals, we're looking at individuals within the sample. So just a reminder what a sampling distribution is. So a sampling distribution is a distribution of values of a statistic in all possible samples of size n from the population. So for that previous example, if I took many samples of 1,500 students and asked them whether or not they applied to colleges other than the one they are attending and calculated a p-hat for each of those samples and put it on a graph, this would be a sampling distribution. It's basically like a graph of a bunch of p-hats or a graph of a bunch of x-bars, depending on if we're looking at means or proportions. All right, so to better understand what a sampling distribution is, so once we have our little distribution of p-hats, right, here's our distribution of a bunch of p-hats, okay? The center of our distribution, we call the mean of p-hat, the mean of our sampling distribution, that's the notation we use. That's going to be equal to whatever the true population proportion is, so that we would say that that's an unbiased estimator. The spread of our distribution, so remember this is basically like socks, shape, center, and spread. The center of our distribution, we use a symbol. It's the standard deviation of p-hat, or sigma of p-hat. That's going to be equal to the square root of p times 1 minus p over n. So whatever p is, we plug that in, divided by our sample size. That is our standard deviation of our sampling distribution. And then the shape of our distribution, we say that it's approximately normal if n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So let's look at, in order to answer this question that we saw right here, in order to answer this question, 3 conditions must be met, and those are called the conditions of inference. So the first condition is the independent condition, and that states that the sample must be less than 10% of your population, or you can say that the population is larger than 10 times the size of your sample. Both are true statements. They're the same thing, just opposites. You usually need to assume this to be true because you never know the true size of the population. So how to check this? Big N represents the size of your population is greater than or equal to 10 times your sample. So again, we don't usually know how big of our population is, but we can usually define our population in words. The normal condition is that the expected number of successes and failures is more than 10. So again, when looking at this example, when we're talking success, we're talking about students who applied to colleges other than the one they're attending, and a failure would be students who did not apply to colleges other than the one they're attending. So if that number of successes and the number of failures is greater than or equal to 10, then we would say that it's approximately normal. So we would do n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Lastly, the random condition, this is that the sample is randomly selected, and how to check that, it's usually stated in the problem. All right, so let's actually go through this example here. Okay, and I'm going to basically lay it out as a 5-step process. So step 1, we're going to identify n, p, and p-hat from this problem. So n is our sample size. So that's going to be 1,500, and I know that that's my sample size because it says an SRS of 1,500 first-year college. So that's a simple random sample of 1,500 college students. P is our population proportion. So it says 35% of all first-year college students. So 35% of all, that keyword all tells me that that is a parameter and not a statistic. And then lastly, it says we need to identify p-hat. Well, this is saying less than 32% of students in the sample. So I know that 32% is referring to the sample, which means that the 32 must be a statistic. All right, so writing this out, n in this case is 1,500. P in this case is 0.35. And then p-hat is going to be 0.32. All right, step 2, we're going to find the center and spread. So the center is a mean of our sampling distribution, and the spread is a standard deviation of our sampling distribution. Well, the mean of our sampling distribution, that's how we write it, is equal to whatever p was. And remember, p in this problem was 35%, so 0.35. And to get sigma of p hat, we're just going to plug in p and n. So it's going to be 0.35 times 1 minus 0.35 over 1500. So when we put that in our calculator, 0.35 times 1 minus 0.35 over 1500, take the square root of all that, we get 0.0123. So I'm going to round to 4 numbers after the decimal. 0.0123. Okay. The next step, we need to check our conditions, because in order to use our z-score table, we need to check that our conditions are met. So the first condition is our independent, is that our population is bigger than 10 times our sample. So again, we don't know how big our population is. However, we can define our population in words. In this case, our population is all first-year students. Is greater than or equal to 10 times our sample, which is going to be 15,000. So we have to ask ourselves, is it reasonable to assume that there are more than 15,000 first-year college students, since that's what this inequality is saying? The number of all first-year college students is greater than or equal to 15,000. I think that's reasonable to assume, so we're going to write reasonable to assume. All right, our next condition is a normal condition, so we need to just plug in n and p. So 1500 times 0.35. So I'm just going to do that on my calculator off to the side. So 1500 times 0.35, that's 525. So this is basically saying that 525 college students in the sample said that they applied to colleges other than the one they're attending, so that's correct. 525 is greater than or equal to 10, and then we're going to do 1500 times 1 minus 0.35. Which is 975. So 975 students in the sample said they did not apply to colleges other than one they're attending. That's also greater than or equal to 10. So then we're going to say it's approximately normal. So our sampling distribution is approximately normal. And lastly, our random condition, it states SRS. So we're going to say SRS is stated. So that third condition is met. So now we can move on. Because our conditions are met, we know that we can move on to our calculations, which is finding the z-score and the probability. Okay, so we know our z-score formula is x minus the mean over the standard deviation. Well, remember, the mean is equal to p, the standard deviation is equal to p times 1 minus p over n, square root of all of that. So this is essentially what we're doing. Remember, we found this and this in step 2. Okay, and p hat we identified in step 1. So p hat is 32%, so it's going to be 0.32. Remember, the mean of our sampling distribution is 0.35. And the standard deviation we found in step 2 is 0.0123. So when we put that all into our calculator, we get negative 2.44. And since we are using z-scores, I know to round to 2 numbers after the decimal. The other thing we need to do in order to find our probability is we have to look for keywords that tell us either less than or greater than. So in this problem, it does say less than. So we're trying to find the probability that z is less than negative 2.44, which means we can look up negative 2.44 in our z-score table and just use that value. All right, so here's my z-score table. I have negative 2.4. I'm going to go over to 4. So that's going to be 0.0073. So this is the probability that we're going to use. All right, so that's going to be 0.0073. So 2 answers in this step, my z and my probability. So lastly, we're going to answer in context. So the easiest way to answer in context is to state the question as a statement. So it says, what is the probability? So I'm going to say the probability that less than 32% of students in the sample applied to colleges other than the one they are attending is 0.0073. Okay, the other way to interpret that is kind of in the repeated sampling way. So basically, remember, sampling distribution is if we were to take a bunch of samples of 1,500. So this is saying if I were to take a bunch of samples of 1,500 and ask them how many of you applied to colleges other than the one they are attending, approximately 0.73% of those samples would have less than 32% of students who apply to colleges other than the one they are attending. Okay. So now let's look at another example. So it says a club at UC Davis interviews an SRS of 267 female undergraduates. Okay, and it says suppose that in fact 70% of college women have been on a diet in the past 12 months. Okay, it says what is the probability that 75% or more of the women in the sample have been on a diet? All right, so identifying N. N is our sample size, so that's going to be 267. P is our population proportion, so it says in fact 70% of college women, so that's going to be 0.70, which also tells us that our population is college women. Since we know that parameters describe the statistic, parameters describe the population. And then lastly, P hat, in this case, is going to be 0.75 because it says 75% of more of women in the sample. So we know that that is a statistic because it describes a sample. All right, now let's find the center and spread of our sampling distribution. So the mean of our sampling distribution is equal to whatever P is, and in this case we know it's 0.70. And then sigma of P hat, we're going to plug in P and N, so 0.70 times 1 minus 0.70 divided by 267. All right, so when we plug that in, we get 0.0280. Now we're going to check our conditions. So for our independent condition, we need to define our population, which we kind of did in step 1. So N represents college women. So it's not college women who have been on a diet because that's the question we're asking them, but we're sampling all college women or female undergraduates. That has to be greater than or equal to 10 times 267. So that's 2,670. So is it reasonable to assume that there are more college women than 2,670? That's definitely reasonable to assume. So the independent condition is met. Now for our normal condition, we're going to do N times P, so 267 times 0.7. So 267 times 0.7, that's 186.9. That's greater than or equal to 10, so that's good. And then 267 times 1 minus 0.7. Which is 80.1. That's greater than or equal to 10, so that's good. So then we would say that our distribution is approximately normal. Okay, lastly, random. Sorry, I'm using the wrong color here. It does say SRS, so SRS is stated. So we know that our sample is randomly selected. All right, now for our calculations, we need the z-score and the probability. Remember, we're going to use what we found in step 2. So p hat is going to be 0.75. The mean of our sampling distribution is going to be 0.70 divided by our standard deviation, which was 0.0280. So when we put this in our calculator, we get 1.79. So there's z. And then we're trying to find the probability that z is, it says, or more, greater than 1.79. Meaning when we look at our table, we know we're going to subtract from 1, or some of you know it is we're going to look at the opposite. So I'm going to look up 1.79 in my table. So I have 1.79 is going to be 0.9633. So 1 minus 0.9633, we get 0.0367. So here's our z, and here's our probability. Lastly, answer in context. So I'm just going to say this verbally. The probability that 75% or more of women in the sample have been on a diet is 0.0367. Or what we can say is if we took many samples of 267 female undergraduates, approximately 3.67% of your samples would have 75% or more of the women who have been on a diet.